everyone. Welcome to the second part of our Devfest. In the second part, we count with the presence of Prajit. Prajit is a well-known AI researcher. Well, I don't know where to start because he is member of the Forbes Council for this year in terms of tech. He is also a TEDx speaker. He wrote a couple of books, so he has lots of experience, and because he's also an international speaker. Today, Prajit will talk about, well, you develop your ML machine learning model, then you want, of course, to deploy your model. So Prajit will talk us through how we can use TensorFlow extended and the pipelines for doing that. Prajit, on behalf of our team, we would like to express our most sincere gratitude for you to accept our invitation and our challenge. Thank you very much, Prajit.
Thank you so much, Diogo, for that introduction, and thank you for the opportunity. First of all, it feels nice to connect virtually to GDG Madeira, and also for the Devfest and tech session. So, hello again. Hello, everyone. So, I am Prajit Datta. I am here today to talk about production ML pipelines. I'm not going to be talking about ML modeling too much or different architectures. This is really all focused about when you have a model or you wanted to put up or you put it into production so that you can offer a product or a service or some internal service within your company. It is something that you need to maintain over the lifetime of the development or the deployment. So normally when you think about ML, we think about modeling code because it's the heart of what we do. Modeling and the results that we get from the amazing models that we are producing these days, that's the reason we are all here. The results we can produce, it's what papers are written about, for the most part, overwhelmingly. The majority are written about architecture and the results and different approaches to doing ML. It's a great stuff. I love it. I'm sure you do too. But when you move into putting something into introduction or into production, you discover that there are a lot of other pieces that are very important to making that model that you spent a lot of time putting together, available and robust over the lifetime of a product or a service that you are going to offer out to the world so that they can experience really the benefits of the model that you have worked on. And those pieces are what TFX is all about. In machine learning, we are familiar with a lot of issues that we have to deal with. Things like, where do I get labeled data? How do I generate the labels for the data that I have? I may have terabytes of the data, but I need labels for them. Does my labels cover the feature space that I'm going to see when I actually run interface against it? Is my dimensionality, is it minimized? Or can I do more to try to simplify my set, my feature vector, to make my model more efficient, right? Have I got really the predictive information in the data that I'm choosing? And then we need to think about fairness as well. Yeah. And we are serving all the customers, all of the customers that we are trying to serve fairly, no matter where they are or what religion they are or what language they speak or what demographic they might be, because you want to serve those people as well as you can. You don't want to unfairly disadvantage people. And we may have rare conditions too, especially in things like healthcare, and where we're making a prediction that's going to pretty important to someone's life. Especially think about a situation when we are in the middle of pandemic, right? And or any condition that occurs very rarely. But a big one when you go into production is understanding the data lifecycle. Because once you have gone through that initial training, you have put something into the production that's just for the start of the process. You're now going to try to maintain that over a lifetime, and the world changes. Your data changes, conditions in your domain also change. Along with that, you are doing now production software development. Now, so you have all of the normal things that you have to deal with any software development, any software deployment. Things like scalability. Will I need to scale up? Is my solutions ready to do that? Can I extend it? Is it something that I can build on? Modularity, best practices, testability, monitoring, safety, anything. How do I test an ML solution and security and safety? Because we know that we know there are attacks for ML models that are getting pretty sophisticated these days. Google created TFX to address this. They created because they needed it. Yeah, that's why, like, you can see these production issues are in any companies which are handling big data. They needed something that would be maintainable and usable at a very large production scale with large data sets and large loads over a time. So TFX has evolved from earlier attempts. Like, it is nothing like done at one shot. And it's now what most of the products and services at Google use. Any sort of machine learning service you see, uh, TFX is actually one of the core component in the underlying technology. Now their vision is to provide a platform for everyone to use. Along with that, there is some best practices and approaches that they're trying to really make popular in the world. Things like strongly typed artifacts, so that when your different components produce artifacts, they have a strong type. Pipeline configuration, workflow execution, being able to deploy on different platforms, different distributed pipeline platforms using different orchestrators, different underlying execution engines, trying to make that as flexible as possible. These are some horizontal layers that tie together the different components in TFX. We'll go through many components here in a little bit. And then we also have a live demo for our audience where they will be going through the components, where we'll show you some of the code and some of the components in that. Like, I will be going through that. Now, if we see, there are different sort of horizontal layers. The horizontal layers, an important one. There is a metadata storage, or so each one of the components produce and consume artifacts. You want to be able to store the those, and you may want to do those comparisons across months or years to see how did things change, because change becomes a central theme of what you are going to do in a production deployment. This is a conceptual look at the different parts of the TFX. On the top, we have a task, a conceptual look at the task. So things like ingesting data or training a model or serving a model. Below that, we have libraries that are available, again, as open source component that we can leverage. They're leveraged by the components within TFX to do much of what they do. And on the bottom row, in the orange, we have the TFX components. These are the components which are in the later part I will be going to show you through my code. And we are going to get into some detail about how our data will flow through those TFX pipeline to go from ingesting data to a finished trained model on the other side. So what is a component here? A component has three parts. This is a particular component, but it could be any of them. Two of those parts, the driver, the publisher, and the largely the boilerplate code that you could change. Mostly you probably won't. So that is that. A driver consumes artifacts and begins the execution of your component. A publisher takes output from the component and puts it back into metadata. The executor is really where the work is done in each of the components. And that's also a part that you can change. So you can take an existing component, override the executor in it, and produce a completely different component that does completely different processing. Each of the component has got a configuration. And for TFX, the configuration is written in Python. And if you see here, it is usually fairly simple. Some of the components are a little more complex, but most of them are just a couple of lines of code to configure. The key essential aspect here that I have alluded to is that there is a metadata store. The component will pull data from that store as it becomes available. So there is a set of dependencies that determine which artifacts that component depends on. It will do whatever it's going to do, and it's going to write the result back into the metadata. Over the time of a model deployment, you start to build a metadata store that is a record of the entire lifetime of your model. And the way your data has changed, the way your model has changed, the way your metrics have changed, it becomes a very powerful tool. Components communicate through metadata store. So an initial component will produce an artifact, put it in the metadata store. The components that depend on the artifact will then read from the metadata store and do whatever they are going to do. They put their result into it and so on. And that's how we flow through the pipeline. So the metadata store, I mentioned what it is. What does it contain? There is really three kinds of things that it contains. Trained models or just artifacts. They could be trained models. They could be data sets. They could be metrics. They could be splits. There's a number of different types of objects that are in the metadata store. Those are grouped into execution records. So when you execute the pipeline, that becomes an execution run, and the artifacts that are associated with that run are grouped under the execution run. So again, when you are trying to analyze what's been happening with your pipeline, that becomes very important. Also, the lineage of those artifacts, so which artifact was produced by which component, which consumed which inputs, and so on, that gives some functionality that becomes very powerful over the lifetime of a model. You can find out which data a model was trained on. For example, if you are comparing the results of two different model trainings that you have trained, tracing it back to how the data changed can be really important. And we have some tools that allow you to do that. So TensorFlow, for example, will allow you to compare the metrics from say a model that you trained 6 months ago and the model that you just trained now to understand, or now to try to understand. I mean, you could see that this was way different, but why is it different? A warm starting becomes very powerful too, especially when you are dealing with large amount of data that could take hours or days to process. Being able to pull that data from cache, if the inputs changed, if the inputs haven't changed, or rather than rerunning that component every time, becomes a very powerful tool as well. So there is a set of off-standard components that are shipped with TFX. But I want you to be aware from the start that you are not limited to those standard components. This is a good place to start. It will get you pretty far down the road, but you will probably have needs you may or may not. So where you need to extend the components that are available, and you can do that. You can do that in a couple of different ways. So here I've opened a canonical pipeline that we talk about so on the left. We are ingesting our data. We flow through, we split our data, we calculate some statistics against it, and we'll talk about this in some detail. We then make sure that we don't have problems with our data and try to understand what types our features are. We do some feature engineering, we train. This probably sounds familiar, right? If you have ever been through an ML development process, this is mirroring exactly what you always do. Then you are going to check your metrics across that, and we do some deep analysis of the metrics of our model because that becomes very important. And I will talk about an example of that in a little bit. And then you have a decision, because let's assume you already have a model in production and you are retraining it, or maybe you have a new model that you are training, and the question becomes, should I push this new model to production, or is the one I already have better? Many of you probably had the experience. If you trained a model, it actually didn't do as well as the old one did. Along with that, we also have the ability to do bulk inference on inference requests. So you may be in a batch request environment. So you're pulling in data in batches and you are running request against it, and then taking that result and doing something with that. That's a very common use case. This is actually kind of new. We have components to do that as well. This is a Python framework of defining a pipeline. So that's a particular component. It's the transform component and the configuration that you need to use for that. But on a very simple level, that's how you set up components. And in the bottom, you see there's a list of components that are written in that call. Those are going to be expressed to a runner that runs on top of whatever orchestrator you're using. So a little bit more complex example, a little bit harder to read, gives an idea. There is several components here. The dependencies between the components and the dependencies and the artifacts that I just talked about are defined in code like that. So you will see, for example, statics gen depend on the example gen. So let's talk about each of the standard components. Example gen is where you ingest your data, and it is going to take your data. It is going to convert it to TensorFlow examples. This is actually showing just two input formats, but there is reasonably long list of input formats that you can have. And it also do your splits for you. So you may want just training and eval, or maybe you want a validation split as well. So what does validation split as well? So what does example gen does then, and then it passes the result into statistics gen. Statistics gen, because we all work with data, we know you need to dive into the data and make sure that you understand the characteristics of your data. Well, statistics gen is all about doing that in an environment where you may be running that many times a day. It also gives you tools to do visualization of your data. So for example, that's a trip start R feature for this particular data set, and just look at that, or just looking at the histogram tells me a lot about that area that I need to focus on. The six, if you see my mouse, the 6 o'clock hour, we have a very little data. So we wanted to go out and get some more data, because if I try to use that and I run inference request at 6 a.m., it's going to be overgeneralizing, so I don't want that. Schema gen is looking at the types of your features. So it's trying to decide, is it a float? Is it an int? Is it a categorical feature, or is it a category feature where what are the valid categories? So schema gen tries to infer that, but you as a data scientist need to make sure that it did the job correctly. So you need to review that and make any fixes that you need to make. Example validator then takes those two results, the schema gen and the statistics gen, and it looks for problems with your data. So it is going to look for things like missing values, values that are 0 and should not be 0, categorical values that are really outside the domain of the category, things like that, problems in your data. Transform is where we do feature engineering, and transform is one of the more complex components. As you see from the code there, that could be arbitrarily complex, because depending on the needs of your data set and your model, you may have a lot of feature engineering, but you may have a little bit. The configuration for it is fairly standard. Just one line of code there with some configuration parameters. But it has a key advantage in that it's going to take your feature engineering and it's going to convert it into a TensorFlow graph. That graph then gets perpended to the model that you're training as the input stage to your model. And that's what it does. It means you are doing the same feature engineering with the same code exactly the same way, both in training and in production. When you deploy to any deployment targets, so that eliminates the possibility that you may have run into where you have two different environments, maybe even two different languages, and you're trying to do the same thing in both places and you hope it's correct. This eliminates that. We call it training serving. So it eliminates that possibility if you see in this here. So let's start with trainer. We are coming back to the start again. Trainer does what we started with. It's going to train a model for us. So this is TensorFlow. And the result is going to be a saved model and a little variant of the saved model. The eval saved model that we are going to use, it is a little extra information that we are going to use for evaluation. So trainer has the typical kinds of configuration that you might expect. Things like the number of steps, whether or not to use the warm starting, and you can use TensorBoard, including comparing execution runs between the model that you just trained and the models that you have trained in the past for some time. So TensorBoard has a lot of very powerful tools to help you understand your training process and the performance of your model. So here is an example where we are comparing two different execution runs. Evaluator uses TensorFlow model analysis, one of the libraries that we talked about at the beginning, to do some deep analysis of the performance of your data. So it's not just looking at the top level of your metrics like AUC, RMSE, or AUC for my whole data set. It's looking at individual slices of your data set and slices of the features within your data set to really dive in at a deeper level and understand the performance. So that things like fairness become very manageable by doing that. If you don't do this sort of analysis, you can usually have gaps that may be catastrophic and in the performance of your model. So this becomes a very powerful tool. And there is some visualization tools that we will look at as well that help you do that. Model validator asks that question that I talked about a little while ago, where you have a model that's in production and you have this new model that you just trained. Is it better or worse what I already have? Should I push this thing to production? And if you decide that you are going to push this into production, then pusher does that push. Now, production could be a number of different things. You could be pushing into a different, if you could be pushing into a server cluster, serving cluster using a TensorFlow serving. You could be pushing into a mobile application using TensorFlow Lite. You could be pushing it to a web application or a Node.js application using TensorFlow. Or you could be even just be taking that model and pushing it to a repo with a TensorFlow hub. Then that you might use later for transfer learning. So there is a number of different deployment targets, and you can do all the above with bulk, pusher. Now, there is a bulk infer. Bulk infer is that component that we talked about a little while ago, where we are able to take bulk inference requests and run inference across them and do that in a managed way that allows us to take the result and move it off. All right, orchestrating. We have a number of tasks in our Pipeline. How about we orchestrate them? Well, there is a different ways to approach it. You can do task-aware pipelines where you simply run a task, you wait for it to finish, and you run that next task. And that's fine, that works. But it doesn't have a lot of advantages that you can have with a task or a data-aware pipeline. This is where we get our metadata. So by setting up dependencies between components and our metadata artifacts in a task, and data-aware pipeline, we are able to take advantage of a lot of information over the lifetime of that product or service, that all the ML deployment that we have in the artifacts that we have produced. Orchestration is done through an orchestrator. And the question is, which orchestrator do you have to use? Well, the answer is you can use whatever you want to use. We have 3 orchestrations that are supported out of the box: Apache Airflow, Kubeflow for Kubernetes containerized environment, and then Apache Beam. Those 3 are not your only selections. You can extend that to add your own orchestrations. But in the end, you are going to end up with essentially the same thing, regardless of which orchestrator you are going to use. You are going to end up with a direct acyclic graph or dog that expresses dependencies between your components, which are really a result of artifacts that are produced by your components. So There are different sort of dogs. You can do it. It can be looking different, but it is the same only. So I want to address this. What's the cube thing and that TFX thing? So what's the difference between the two? The answer is Kubeflow is really focused on Kubernetes containerized environment. And it's a great deployment platform for running in a very scalable, manageable way. Kubernetes platform uses TFX. So you're essentially deploying TFX in a pipeline environment on Kubernetes, and that's Kubernetes pipeline. But TFX can be deployed in other ways as well. But if you don't want to use Kubernetes Kubeflow pipelines, and if you want to deploy in a different environment, maybe on-premise in your own data center or in your own data center or what have you, or you can use TFX in other environment as well. One of the things that we do, because we are working with large data sets, there's a lot of processing involved. Some of these operations that we are going to do require a lot of processing. We need to distribute the processing over a pipeline. So how do we do that? Well, a component that uses a pipeline is going to create a pipeline for the operations that it wants to do. It's going to hand that pipeline off to cluster. Could be a Spark cluster, could be a Flink cluster, could be a cloud data flow, MapReduce, happens on the cluster. And it comes back with a result. To support more than just one or two types of distributed pipelines, working with Apache Beam, to add an abstraction from the native layer of those pipelines so that we can take the same code and run it actually on different pipelines without changing your code. And that's what Apache Beam is. There are different runners for different things like Flink and Spark. There's also a really nice one for development called the direct runner or a local runner that allow you to run even just on a laptop. But here's the vision of a beam. There's a whole set of pipelines out there that are available. They have strengths and weaknesses, and in a lot of cases, you are already have one that you have stood up, and you want to try to leverage that resource. So by supporting all of them, you are able to do this installation. You don't have to spin up a completely different cluster to do that. You can leverage the ones and you just expand the ones that you already have. So Beam allows you to do that. And also with different languages. Now in this case, we are only using Python, but Beam as a vision as an Apache project allows you to work with other languages as well through different SDKs. Now we're moving on to the next part. I will be quickly going through the demo, and I request all the participants, if you are on your laptop or on your and having a good screen and all, or a bigger screen, you can just click on this link. It's www or https:/tinyurl.com/mldevfest2020. So there will be a Google Colab notebook will open, and I will be giving an overview of that. So again, I repeat tinyurl.com/mldevfest2020. So now we are here. I think you all are with me. So this is a really very interactive pipeline where you can see how different components of TFX are there and how you can create a pipeline and how you can download that pipeline, and also what are the different how you can use those things. So first we start with installing the pip install, because in Google Colab, because of the first time when you run this cell, you need to restart again the runtime. So you can see in my screen, I think it's working. It is going to take some time, it seems. But yeah, let's go ahead with this because this is the only part which will take some time. So it's installing all the packages. In the meanwhile, if you have any questions, feel free to ask me up.
Well, Prajit, I can ask you a question. So for those of you who are starting in this machine learning thing, what are the resources that we need to follow, meaning about most recent papers that combine, because these machine learnings combine lots of hard math things. So do you have any online resource or any book that you can suggest us to follow?
Yes, I can speak on that. Yeah. So it depends on like if someone is starting really from scratch. There is one very interesting course in Coursera called AI for Everyone. It's by Andrew Ng. And that course is basically talking about machine learning without not doing a single pinch of code. Like it's just like a storytelling course. But it really gives a very broad perspective. You can have set the motivation. And also it touches on terminologies. It is not like that, but you don't need to code and you can understand the concept. And then you can either do a Google machine learning crash course, which is available for free and anyone can access that. Or else you can take Stanford machine learning course. Again, it's by Andrew Ng, which is really popular, one of the best courses in Coursera. But Google Machine Learning Crash Course, I personally liked it because then you will be really catching up with the modern technologies, which is not that much covered in the Coursera, in that course, the machine learning course, because it's an old course. In Google Machine Learning Crash Course, you can see a lot of, new technologies like TensorFlow and all. They have covered it. They have updated it well. So yeah, yes, please.
I was saying that now recently we have lots of tools, for example, TensorFlow, which can, leverage the development of machine learning and other artificial intelligence tools. Can you talk us through what are, the other things that you can do with TensorFlow while this downloads the packages?
No, it's done actually. So basically, you want to know what sort of other things TensorFlow can do.
Yeah.
So basically, TensorFlow, as per the developments, it can do almost everything what we need to start with. It has got some limitations, but let's see the positive side of it. If someone is a really beginner and all, it can do classification, clustering, any sort of thing. TensorFlow is really can do at the basic level. They have covered everything almost. And in more deeper level, of course, there are some limitations, but you can think of any algorithm, TensorFlow can handle that. Of course, it is more known for the object detection and all, which is like a benchmark, like TensorFlow was mostly known for that. But it's improving. The community as well as the developers at Google, they are putting a lot of effort. So not just like that. So with TFX and lot of things like TensorFlow.js has got is very incredible. TFX is incredible. You get a lot of customization and connections and pipelining. So things are better.
Yeah. So yeah, now I think we are ready to continue with the demo. So
Yeah, sure, Diego. Thank you. So I have installed all the packages, but after you install the packages, you can click on the restart runtime because I need to get a fresh start of all that. And then you need to import packages. It's importing packages. So after it imports the packages, you can check, let's check the library versions. You can check the library versions. It's TensorFlow 2.1.2. and TFX version is 0.21.5. Now setting up the pipeline paths, like you remember those canonical diagram, if you recall what I have delivered in the talk. So it has set up the pipeline paths, and then let's download an example data. You can see there's a taxi trips data set. Trip start are these are the variable names or the, so you can see fare, trip start month, trip start timestamp, drop of latitude, pickup census, company, payment, and all. So we are importing this data set. You can go and investigate more on the data set. Now take a quick look at the CSV, how it looks like. So this is how it looks like. You can see here. Now let's create an interactive context. In TFX, while you're doing, you can start up an interactive context with just 2 lines of code. You can write context.run, and you can call the context interactive context function, and then the context.run, and you just pass up that, and it will show you how it looks like. So which will alert you interactively in this notebook. Now let's run all the TFX components separately. The first one goes with example gen. So the example gen is a pipeline. It will split the data into training and evaluation sets. It will convert data into tf.example format and copy a data to TFX root directory for more components to access. So we have got it done here. Now let's examine the output facts of the example gen. The component produces 2 output facts, that is training examples and evaluation examples. So you can see that here it is providing those training and evaluation examples here, which it has stored in here. And now let's look at the first 3 training examples. If you click into that, so you can see the features are coming like this in way. So that's how it looks like now. Now with that example gen is done. Now let's move on to the statistics gen. The statistics gen is really important. It gives you more of a, statistics over a data set, or how it looks like, or what. It's a basic thing when we do data preparation or the statistical analysis, the EDA part. Now we can also get an interactive part of that, and where we can see how it looks like. If you see it here, you can see all the graphs coming up. You can see how much is it the mean, standard deviation, zeros, and different sort of graphs, and you can change to whether you can go with the quantiles, whether you can go with the value last length and all. So this is the evaluation split, and you can see it here. You can also change the feature order. It's very interactive, You can also see what values are coming up and all. That's what it is. That's a powerful tool, right? Powerful component of TFX. Now schema gen, if you remember, I told you that it checks out the schema of the data. Now here we'll take the input the statistics. So basically now the data it is taken from the statistics that we generated from the statistics gen. Look into the training split by default. And then after that, the schema gen, you can visualize the whole schema. And also it will you can also see that, okay, if some of them are not in a proper schema, it will also tell you that. And also you need to have some domain knowledge to take a judgment call on that. With that being mentioned, let's move on to the example validator. So this is an example validator. You can see that detects anomalies in your data based on the expectation defined by the schema. It also uses the TensorFlow library, TensorFlow data validation library, this example validator. So it is validating the data sets. So we can also visualize the anomalies as a table. You can see it here. It is coming up how it is unexpected string values for the company, payment type. So it is validating and just giving it back. Now moving into the transform. Now this transform component performs feature engineering for both training and serving. So as the data transform, it's the same thing only. So it does that for you. So you can see it is actually transforming all the particular items what we are feeding in, and it is transforming to a so this will like contents of the cell as a py on the disk, and this will transform the component of the cell as a module. Then we are doing a processing of that. We write the processing function. So this is the Python file we are getting up, and then we are transforming our model on the train data. So it is writing the taxi transform.py. Now we pass the feature engineering code to the transform component and run it to transform your data. So it is transforming. So it has transformed. You can see it here. And then the example of let's examine the output artifacts of the transform. You can see we are seeing the output artifacts, how it looks like and all. And take out the peak, take a peek at the transform graph also. So the transform metadata subdirectory contains the schema of the process data. The transform function contains the actual pre-processing graph. You can see it here. And then we are going with the trainer. As soon as we put up the pipeline, and also we are going with the trainer, and now it is user-defined model code. So here you can see it's coming up. I think it is done. Yeah. Now we pass the model code to the trainer component and run it to the train model to train the model. Then analyze the training with oh wait, the trainer is still working. This trainer takes some time.
Prajit, hey, what type of tool are you using to train the model? Like, are you training an artificial neural network? What are you training? Sorry.
So basically, in this case, you are saying,
Yes,
yeah,
yes, yes.
we're defining the no, but yeah, basically we're defining that only. So it is trying to check out that what we can do and what sort of model we can feed in based on the model performance. So based on the model performance, you can take a call that which sort of model you should take it up. So I think our trainer is done by then. No, it's still going on. Just I need to wait for this. So you can see there are different model, the baselines and all are given. Like the Diogo asks me that what sort of model we are going off with. So it is actually trying and testing up with different model accuracies and sharing the benchmark that what is which one to go with. It is also sharing the accuracy, a UC curve, the precision call data. So it is taking its own judgment. You can see how it is training with each segment. So basically in the TFX pipeline, you should use like TensorFlow 2.x with Keras models via the generic trainer. So it is just trying to pick the models from the Keras and we need to still waiting. It will be done soon. I'm sorry I'm overshooting the time, but we are at the end only.
Yeah, don't worry, Prajit. You can take your time.
Yeah. Just a few more minutes. We are at the end. I actually, before this session, I ran the session, but again, it got refreshed, so I need to do it again. So that's the reason. I thought of getting it prepared, but it was, cool. So we are finishing up now. The evaluation is going on. You can see TensorFlow evaluation is going on. Awesome. We are done with the training part. Now analyzing the training with a tensor board now. So you can see a tensor board is launching now. So you can see different sort of, you can play with the tensor board and see, take a model judgment on that how it is performed and how everything it is here. You can see also it has given the graphs. And when it comes to like distribution, you can see the distribution and the related histograms. With that being mentioned, let's evaluate the evaluator component. The evaluator component computes model performance metrics over the evaluation set. It uses the TensorFlow model analysis library. Now we give this configuration to the evaluator and run it. Special configuration depends on what sort of configuration you're writing, You can also change it. Now we can, Now we can also examine the output artifacts of the evaluator. At the same time, we can show the default visualization of the goal metrics of entire evaluation set. So you can change up example. You can increase the threshold and see how the accuracy of and all of different different models. Now to see the visualization of the sliced evolution matrix, we can directly call the TensorFlow model analysis library. You can see here. So this can be also again sliced to an individual column level. It's very granular we can do. And then you can also, export this part, and you can also verify the success by loading the validation result record. And then the next part is pusher. As the name defines, the pusher component is usually the end of the TFX pipeline. It checks whether the model has passed the validation. If so, it exports the model to the production environment, to the serving directory. And that's how it is. So model will export your model into the same model format, and which looks like this. And then you can actually export to a pipeline. You can store it in a Google Drive and all to save space. You can give an authorization code and it will save it for you. You can select an orchestrator, whether a Beam or Airflow. You can set a path. You can choose components to include pipeline or generate pipelines, or also you can download the pipelines. So it's pretty easy. There are so many things are there. So you can do enormous number of things with this, and you can get started, and you can create a pipeline and export the pipeline through TFX. And the best part is that even the inputs are same, you can kind of change it again, and you can get the results. So this was a short talk from my end on TFX, and also a demo from my side. So that's all from my side. Thank you so much to the team, and thanks for the opportunity.
Hey, we should thank you, Prajit. So I have here two questions. The first one, we saw that we had like two winters in the AI world. So the first one was caused about, I think, linear separable things with the short gate. And there is one other winter that, if I'm not mistaken, was caused because of the machine power that we had at that time. So do you think that maybe we will have a third winter, but in this case not caused by mathematical problems or not by our machine performance, but by our people? So people that want to like kill the artificial intelligence worlds because they are afraid that machines will replace them in some time.
So I got your question, but you are saying me that how machines is going to replace humans. That's what you ask, or what exactly?
So basically, we had two winters in the AI world, right?
Two winters.
Yes, two parts of the history where the artificial intelligence world will not be explored by our scientific community. Then we are now facing a new problem because people don't want that artificial intelligence probably will replace some work.
I think that I don't know why. Like, if you see the historical data and all, basically, people should not think like AI is like a robot who is replacing the human completely. It's one of the automation. Of course, it is intelligently automated. And automation has always helped the human race in the past. When machines came in, the clothing industry, lot of jobs were lost.
Yeah.
Earlier, people used to, do it manually and all, the cloth weaving and all. But actually, it generated 20% more jobs than the previous than it used to be in the past. The reason being when it was machine, it was a demand of the supply chain network, and due to the demand, like it was very fastly produced and all the clothes. The supply chain network was really active, and which creates a lot of demand and cheap clothes. So people, the labor was there was a lot of requirement in labor in those industries. Eventually, they were doing something else, not the manual job. They're controlling them, they're operating the machines, or they're being part of the supply chain.
Mhm.
But the job loss was not there. Job transformation happened. So with the AI, the job loss will not happen. Job transformation will happen, and it will exponentially grow. The number of unemployed people will reduce, and employment will grow. So that's how I see it, and that's what the historical data says. And data cannot be right, and data cannot be wrong in most of the time. Like they are always right. So I think that it is positive.
Yeah, thank you very much. So the last question is about yourself. Can you talk us through what are your projects right now? What is your future works that you're going to pursue?
Definitely, I can. Though there, I can do. I can touch on some of them. Like mostly, I work on now object detection, ML algorithms. So lot of we are part of European region, and GDPR is very strong here. We cannot collect data and all. So basically, we are creating smart algorithms which can run on the edge devices and can get us better results. So we are working on those type of those type of projects are around that. Whether it is tied up with safety, whether it is tied up with um, whether it's tied up with some kind of a surveillance and all. So even social distancing detector when when it comes to the corona crisis time, like the people are maintaining social distance around. So we have developed those algorithms, and now we are kind of making it into a full-fledged product. We are on our journey. So we
Yeah,
have done, we have got a good response, but we are still working on that.
yeah, it seems interesting. So since we do not get any questions from the audience, the only thing that remains to do is to thank you, Prajit, for your effort and for being available on a Sunday to give us a talk about machine learning. Thank you very
Thank
much.
you so much, Diego. Thank you.
See you. So to end this Devfest, the DDG Tech Sessions Devfest, let me just go through here a brief explanation. So don't forget to fill out this feedback form because you will get the opportunity to receive free swag if you earn it. Then don't forget to also subscribe our channels. As I already told you, we have here a handful of tech topics. Today we will increase, this family or this set with two more interesting talks. So don't forget to subscribe our channel. And I want to thank you, all the speakers. I want to thank all the staff behind of the GDG Tech Sessions for organizing this amazing and this first DevFest with this initiative. And I will be, and we, the team, will be here on the future events of the GDG Tech Sessions. So stay tuned, please, to our social networks because we will give some news soon. Okay. Thank you very, very much to all of them.